I'm going to be speaking today about the angle addition postulate. The angle addition postulate extends from our knowledge about segment addition postulate. It gives us an opportunity to demonstrate a postulate, something that is so obvious we needn't prove it, we can accept it without proof. In this case, what we want to say is that the smaller angle here plus the additional angle here together make up this entire angle. In other words, if we begin with this picture, B on the interior of AOC and coplanar with AOC, then when we form ray OB, it produces angles such that the measure of angle AOB plus the measure of angle BOC will equal the measure of angle AOC. That's the angle addition postulate. In practice, what does that look like? We can apply it to problems, for instance, if we're given algebraic components for each. The importance of this theorem, or in this case a postulate, lies in the ability to create an equation that makes sense. Now, whenever I see a series of x's, expressions with x's and constants, variables and constants, I know I have to create an expression or create an equation to tie them together. However, oftentimes people don't know exactly how to create the equation. Do I add the first two to equal the third? Do I make the first equal the last two? In this case, I think most people probably, without thinking it through, would set up this. 3x plus 15 plus 5x plus 20 equals 8x minus 43. Now that I've got this in front of me, I immediately go to solving. That's what we've learned to do in algebra, so that's what we would fall back on. I'd combine like terms. However, as you'll notice in this case, I get a solution that doesn't make a lot of sense. I didn't find the value of x. I found that 35 equals negative 43. Whenever I have an equation, what I'm really asking myself in solving it is, when is this true? In this case, this equation is only true when 35 equals negative 43, which is never. This was not set up correctly. Instead, I need to apply the angle addition postulate. I need to begin by looking at my picture and say, what do I know? Well, I know that this angle plus this angle, the red one, plus the blue one, together make the purple one. Once I begin with this statement, the result of my angle addition postulate, I can then substitute to solve. So instead of AOB, I'll pull in 3x plus 15 plus, instead of BOC, I'll pull in 8x minus 43. Instead of measure of AOC, I'll pull in 5x plus 20. This equation now then accurately describes the relationship among the three angles. So I can begin to solve this problem. Again, combining like terms, 3x and 8x is 11x, plus 15 and minus 43 is minus 28, is equal to 5x plus 20. Subtract 5x, add 28, and I reach the solution that x is equal to 8. I should check myself and ensure that in fact this worked out. Did I get 3 times 8 plus 15, which is 24 plus 15 equals 39. 5 times 8 plus 20 is equal to 40, plus 20 is equal to 60, and 8 times 8 minus 43 is equal to 64 minus 43, which is equal to 21. In fact, 39 plus 21 does equal 60. My situation worked out, and these are reasonable angles to solve a geometry type problem. This concludes a demonstration of the angle addition postulate.